I think the power of genetics is it might be slow, but it just cranks along and keeps getting better and better. And we really, I think, if you look at the improvements that have been made over time, and now the indexes are getting things like feed efficiency into them, that is obviously an economically important trait that we would like to select for more efficient animals. All of that, it's kind of a triple win it's better for the farmer, so more profitable, better for the animal because they're healthier and living longer and all of that good stuff, and better in terms of the overall cost of producing a kilogram of beef or whatever the animal product is. So that would be kind of how I see it fits into sustainability. It's that triple win.
Welcome to the Beef Podcast. I'm Travis Mullenix, and today I have Dr. Alison Van Eenennaam with me today. Thanks for jumping on the podcast.
Thanks for the invitation, Travis. I appreciate it.
So today we're going to talk about the role of genetics in livestock sustainability, which you've been a large part of, gene editing, etc., and just genetic improvement. But you are a distinguished professor at UC Davis in extension and breeding and biotechnology. And you've done a lot of research, especially on the dairy side, but some on the beef side as well, of the role of genetics in sustainability, correct?
Yeah. And I know I'm a geneticist, so I have my own inherent biases, but I reckon genetics is a pretty important component of sustainability. And I think if you look at beef or dairy, the genetic improvements that have been enabled by just traditional selection has really obviously improved productivity per animal, and that has the knock-on effect of reducing environmental impact per unit of milk or beef. I think genetics is a very important component of that.
It definitely is, and I think it's a big way forward for our producers of meeting some of these benchmarking goals that there may be. For the audience, kind of give a quick background of how you got where you are and what you're doing today.
Sure. So as you'll probably hear, I'm originally Australian by the accent anyway. So I did agricultural science at Melbourne University and ended up actually doing an exchange year at UC Davis in the senior year of my undergrad, and got to meet a professor here who said, you should come back and do higher degrees. And so I did a master's and PhD at Davis in genetics, and I've been working in my role a little over 20 years now as a professor and extension specialist. So basically taking science to the farmers, that's the kind of the background behind extension as a concept. And so my area is obviously breeding and genetics. And then I also have a research appointment where I do some interesting biotechnology, such as genome editing in ruminants, so sheep and cattle. And so that's a part of my job as well. So research and extension is the two main roles.
Which I think, they feed a large part into each other, and they're critical roles together, right?
I sure try to make them feed into each other, because otherwise you've got two jobs instead of one. So, I try to have stuff that's pretty relevant to the extension mission as part of my research.
Yeah, but it's hard to answer those extension questions if you're not doing research within that realm.
Yep. And certainly do get some interesting ones sometimes. I think the forensic DNA ones are the most interesting, where someone wants to check if their beef has actually come from their animal that they submitted to the butcher, or this type of thing. And so there's all sorts of interesting things that DNA can answer in a way that is very definitive. Yes or no, that's not my cow.
Yeah, you never know when you get a phone call what that question could lead to.
100%.
It does make the job fun a lot of times.
It does, yeah, all sorts of interesting questions.
Yeah, so let's get back to the topic hand of the role of genetics in livestock sustainability. And she's talked about, you kind of been in this realm for a while now, looking at genetics and genome editing, et cetera. I know you've done a lot with hornless dairy side as well, but how does genetic improvement contribute to sustainability of cattle, livestock production, and it could be, both beef, dairy, sheep, since you've been in all of those realms?
So really, it's just a way to produce more efficient animals. And so as we've got more sophisticated with our the traits that we're able to measure and the different economically important traits that go into the overall breeding objective, or the dollar index as it's often called, um, is we're now putting, for example, in dairy production, not as much emphasis on production per se, but more emphasis on an optimal cow. So a cow that doesn't get sick, that has a calf every year, that lives a long time, that also produces a lot of milk. And so I think we've become more balanced with our objectives. And, beef cattle were tiny in the 50s, and then they got giant in the 80s, and now they're back to a more moderate framed animal. And really, it's a matter of optimizing that objective to get the most optimal animal for the production systems. And through all of that, we've obviously, for dairy, I think that a cow today produces about 4 times what she did in the 1950s. So if you just do the simple math on that, it means that like a glass of milk today has about a third of the environmental footprint it did back in the 50s. And similarly for beef, we're getting much more yield per animal. And so we've got less animals, but producing more meat kind of. And it's really that is the beauty of genetic improvement, is once you've made it, it's permanent and cumulative in that it just gets passed on to that next generation with no further inputs. And that's, I think, the power of genetics is it might be slow, but it just cranks along and keeps getting better and better. And we really, I think, if you look at the improvements that have been made over time, and now the indexes are getting things like feed efficiency into them, that is obviously an economically important trait that we would like to select for more efficient animals. All of that, it's kind of a triple win. It's better for the farmer, so more profitable, better for the animal because they're healthier and living longer and all of that good stuff, and better in terms of the overall cost of producing a kilogram of beef or whatever the animal product is. So that would be kind of how I see it fits into sustainability. It's that triple win. So that you love those. You don't get them very often, but especially disease resistance. So there's a disease resistant pig that was just approved. It's a gene edited pig that where basically they've inactivated a gene where the virus gains entrance to the pig and produced a line that's resistant to PRRS, the porcine reproductive and respiratory syndrome virus. And that's a pretty big achievement for Genus, or PIC, they're called here, Pig Improvement Company, and very exciting to see the first application of a disease-resistant animal coming and getting through the regulatory approval process.
Yeah, so you touched on several different levels of sustainability with that, is right, is that there's the environmental standpoint, there's profitability standpoint, and I think we're moving into a lot of societal, as you talk about this PRRS, with is it acceptable, is what's the society thinks of, and the society benefit, et cetera, of some of these. But back to some genetic improvements is we have increased a lot of outputs and did a tremendous job of producing more efficient animals for the output for that given amount of whatever you want to say environmental footprint. But there's other avenues we could chase too, correct? That could also decrease within that growth potential, that can also decrease some environmental footprints.
Yeah, I mean, it's kind of the whole interplay of the 3 basic pillars of animal science. So improved genetics obviously has to be complemented with improved feed and improved health or veterinary care. And obviously healthy, well-fed animals are going to grow better. So you kind of need the trifecta for it all to work hand in hand to some extent. So I guess that, yeah, the disease-resistant examples, I think, are really nice one from the sustainability perspective, because obviously sick animals are not helping the environmental equation, and also not aligning with farmers don't like sick animals either. Animals don't like being sick, and it's just if you can have animals that need less treatment with antibiotics, that aligns with societal values too. So I think that it's such a good story, the sustainability story, that it doesn't get out there much. It's kind of just happening in the background, but it's if you stand back and look at what it's done in terms of reducing the environmental footprint or improving efficiencies, it's really quite a success story. And there's some new technologies coming online now. For example, the use of sex semen in dairy production that enables them to basically just breed the genetically elite cows in their herd to produce replacement heifers, and actually put beef semen in the what's called the low end of the dairy herd. They just need a calf. It doesn't matter if it's beef or dairy, and that's turned into a really great income driver for dairy production, and a way to basically get beef calves on the ground in the context of a dairy operation. And so that has some really positive metrics in terms of environmental sustainability too. So there's the different things you can do messing around with generation intervals and sex ratios and things to actually improve the efficiency of the overall system. And that beef on dairy trend, as it's called, has been it's just taken over in California. Here we have a very big dairy population, and I was just driving up the valley yesterday past Harris feedlot, and that used to be all black and white. It just, when your eyes went over that feedlot, I went over past it yesterday, and it looked like a certified Angus beef feedlot. There was just black cattle all the way back. So that has happened in the course of less than a decade, just total adoption of that technology. So I think when things make sense and they've got the triple line profitability and the sustainability, it just kind of takes off, and with little extension effort, to be honest. So yeah, it's exciting to see.
It does. And that's a big one if you think about everything you talked about from the standpoint of you're increasing feed efficiency when you do it, you're increasing or decreasing days on feed, you got a better end product than you do with a straight bred dairy animal. And so that's just increasing that whole efficiency and decreasing the footprint of the dairy beef complex when they went to beef on dairy.
Yep, and also giving the good revenue source for the dairy producers as well. I think they used to get, I don't know, maybe $50 for a old Holstein bull, and I was on a dairy yesterday. They're getting $1,200 for a day-old beef on dairy calf. It's like unbelievable. And so obviously, that's going to be a big source of income as well, and in addition to the milk check. So that's a good thing. And those types of things have been enabled by biotechnologies like sex semen, and then also combine that with genomic testing that enables them to pick which are the better animals to do the sex semen into, and that opens up the rest of the uteruses, so to speak, in that dairy herd to be available for beef on dairy, or even beef embryos some people are doing now to get straight bred. So yeah, lots of exciting things happening in that space, and you see it in the flesh here in California.
So let's step back a little bit and talk about what are some of the main drivers of genetic improvement for producers.
Yeah, well, there's only really four, and we've kind of known about this since the 30s, really. So there's what's called the breeder's equation is composed of four different things. So it's accuracy. So how accurately can you select which is the best animal? So some people think they can use their eye. I'm a little bit more data driven. I like a good EPD if I have given a choice. Then there is the intensity of selection. So how widely do you use the very best animals? So AI, for example, is a way to increase the intensity on elite males. There's how much genetic variation you have in your population, which is a little bit constrained by probably your breed if you're a straight bred person. And then all of that is you want to increase those. And then there's one you want to decrease, and that is the generation interval, the average age of the parents when the calf is born. And that you can get around kind of some of the biological constraints there by doing things like ovum pickup from young heifers. So elite heifers, you can go in and take immature oocytes using ovum pickup and cultivate them and do IVF and get calves out of her, like 20 calves, before she's actually even cycled herself. Things like that. And so obviously your heifers are always your best animals, should be, if you're doing something right in your breeding program. So the earlier you can use them and the earlier you can use young bulls, and that's where genomics comes in, because you can test them and get a good accurate estimate of their breeding value based on which DNA sections they inherited from mum and dad. And so that can decrease the generation interval too. And that, I think they kind of work together, the different biotechnologies. So there's a lot of assisted reproductive technologies like in vitro fertilization and what have you that kind of intersect with, you need the genomics to know who's the best animal, to know who to amplify using assisted reproductive technologies. And then they all kind of come together with gene editing too. So that's kind of a newer technology where you can go in and introduce a useful characteristic like not growing horns into dairy cattle, for example, or maybe slick, the heat tolerance phenotype that you see in Senepal cattle, for example. You might bring that into an Angus, for example. Those are but you would need to use this reproductive technologies to make that work too. So they kind of all synergistically work together to accelerate the rate of genetic gain. That's I think their tools just fit nicely together.
And that's one massive disadvantage that we have compared to like the swine industry is because think how long it takes for that generation interval to occur on a normal basis and how quickly they can make changes in poultry and swine is they can make rapid changes. It takes us a long time to make changes.
It does, yeah. So we're about three years for a cow in general. By the time the bull's mature and she's mature and got through her gestation, because that's another 9 months versus pigs is what 3 months, 3 weeks, 3 days, something like that. So it is a disadvantage, but there are ways to kind of circumvent it. And over and pickup is one way to do it. But we're still requiring the cattle to sexually mature or at least develop ovaries and produce semen. There's actually even some kind of crazy ideas where maybe you could do gametogenesis on a petri dish. So basically, you could take a cell line from the best bull and the cell line from the best cow, and you could derive oocytes and sperm in a petri dish rather than in a cow or a bull. And then if they undergo meiosis, you could recombine them through in vitro fertilization to basically shorten that generation interval from 3 years down to about 3 months. That's called in vitro breeding. It's a little bit out there, but it's been accomplished in mice. And sometimes that's a harbinger of what's going to happen in cattle in 10 years' time. But so there's some interesting things there that people are playing with in the lab.
So are you saying, the future of beef production is going to be more lab based, not from a lab meat base, but lab and some of these technologies moving to?
Yeah, I think in vitro breeding's still a pretty long ways off. We haven't reduced that to practice in bovines, but I absolutely think that many of the things that are done in labs, such as DNA testing or in vitro fertilization or that type of thing, and maybe even culturing cells that from the elite animal that you want to edit, and then maybe cloning that animal after it's got its desired traits like polled or slick or whatever it might be. I think that there's going to be a lot more assisted or advanced reproductive technologies intersecting with these genomics and genetics techniques to produce animals that then are going to go out into the field. So I don't predict the end of the seed stock sector at this stage. I think they're still going to have a very important role, but probably they're going to be using more lab-based biotechnologies to basically decrease that generation interval and increase their accuracy of selection, and maybe even their genetic variation by bringing in useful alleles from one breed that maybe isn't in their breed germplasm, like the polled example in dairy cattle, for example.
How do you see some of this? And there's data showing, from a genetic standpoint, we can select for low methane animals. How do you see some of that playing into some biotechnology and moving forward with sustainability from that standpoint?
I just got asked this question. I was just at the Methane Summit this week in Davis and was asked to speak on whether we can edit animals to do less methane. It's not that easy. It's not like there's a methane gene that you can knock out and they'll stop producing methane, in part because it's not them making the methane, it's the bugs, right? And so I think that there has been some efforts to select for low methane producing animals, and particularly in sheep in New Zealand, and you can do it. It's a heritable trait, but actually the thing that has really reduced methane efficiency, and by that I mean methane per unit product produced, is our conventional breeding programs. And so, improved efficiencies and productivity always has the knock-on effect of reducing the emissions intensity, and and that's fortunate because it aligns with what you would want to be doing anyway as a rational business person, which would be selecting the most profitable animals. They also happen to be the most efficient, and get pregnant every year, do all the right things, and that reduces the methane emissions. So I think there is a possibility to do direct selection on methane. But I also would look more generally at just what we're doing now actually does that to some extent. And in fact, some of the breed associations now have what's called sustainability indexes that kind of appropriately weight things to really put a foot forward to reduce that methane intensity. And so I think conventional breeding does a great job at trying to reduce methane intensity also, and is perhaps more easily accomplished than the methane measurements, which are very expensive and not very commonly done. And if you don't have a lot of phenotypes, you can't calibrate your prediction equations in genomics, and then you don't really have a very predictive or a very accurate estimate of the methane production. And so that has to be sorted out before we'll be able to reliably and accurately incorporate methane. And then what weighting, economic weighting, should we give it? Because at the moment, there's no real, it's difficult to do that. So is there some sort of an incentive for a producer to do that? Because if you take pressure off other traits that do bring in revenue, then you kind of have to have a rational economic reason why you would be doing weighting it on methane. So I think there's some economics to be done there, and also a lot more phenotypes need to be recorded before we can select in cattle for low methane producing cattle.
For me, I see some of the indirects, like feed efficiency is going to be the big one that will help with a lot of those decreases in enteric methane. So if we can, and we'll also have a big impact on profitability of a producer if we can select for increase in feed efficiency, especially grazing animals. And how does that, help us move forward to sustainability?
Obviously, efficiency is gain per unit of input, and that's obviously an economically important one for cattle producers to consider anyway. And so I think that there will be selection on that because it makes economic sense to do that. And if that, of course, the amount of methane produced is directly proportional to how much indigestible cellulose or roughage is in the diet. So by definition, you're going to produce more when you're grazing versus a feedlot animal on a hot ration. I get a little concerned with this kind of myopic focus on one metric of sustainability, which is greenhouse gas emissions per unit of beef, because the cow-calf sector is serving a very important role in terms of harvesting forage on non-arable lands. And the fact that produces methane because they're eating indigestible cellulose, which is actually their magic superpower, shouldn't count against them, right? They're doing what they're meant to do. They're being ruminants, and really feeding them a corn ration isn't really utilizing their special biological role, which is the rumen. And I guess I don't think it's a broad enough metric to just look at greenhouse gas emissions, because that would lead you to select for the most intensive system on Earth, whereas actually, a well-managed grazing operation, I would argue, is also sustainable, even though the metric of greenhouse gas per kilogram of beef might not be as low as it is in a very intensive system. And I think this myopic focus is problematic because it leads you sometimes to counterintuitive decisions, because you would push for this very, very highly industrial system and discount the cow-calf operations, which are basically producing nutritious food on unarable land, and that's their magic superpower.
Yep, and I think you hit on it earlier, as the story has not been told and not been told well enough that they are the benefit of decreasing the environmental footprint is a big role that the cow-calf industry is is in and will be a part of moving forward.
Yeah, I reckon one of the best ways to do that is to make sure you get cows settled early, and every cow has a calf. That would help a lot. And I realize that's easier said than done, but that's certainly an important role in all of this.
So, Alison, as we wrap up, is there anything you want to touch on that we didn't discuss?
No, I think we're all good.
It's time for our famous three.
Is stress affecting your bottom line? Even routine handling, inclement weather, weaning, and dietary changes can significantly lower the rumen pH, causing cortisol levels to spike. Cortisol not only compromises the immune system, but also suppresses normal appetite and feed consumption. The solution? Cattle Active. Increase production and reduce the impacts of stress on your cattle for cents a day. Cattle Active restores the balance naturally. Want to learn more how a feeding program including Cattle Active can improve both profits and herd health? Visit us today at proearthanimalhealth.com. Be proactive with Cattle Active.
Well, we'll wrap up with three questions here. And the first one is for the audiences, what is your highly recommended beef-related book, resource, website that you recommend them utilizing?
Well, this might be a little bit Australian focused, but I really like the Beef Central website. So that's a media out of Australia, but it's got up to date what's going on down there, and also what's going on with global exports and what have you. So I find that a very useful website for sure.
Great. So what is a non-ag book that you highly recommend someone reading?
So I just finished reading one that's probably a little bit pessimistic to be talking about it, but it was called The Death of Expertise. And it was a really interesting book about how we kind of now got like influencers that are making really important decisions rather than maybe experts in the field. And how do we get there? I thought it was an interesting look at academia, but also more generally media sources and how we've kind of becoming dismissive of people who are actual technical experts in fields that like take a lot of training to get expert in. And so I do feel like, there has to be some deference given to people who have actually studied something their whole lives versus Joe Blow on the couch who has an opinion. And that's, I think, a challenge that we're facing at the moment. There's so many experts that aren't actually experts in the field that they're discussing, and it leads to a lot of incorrect information out there.
Unfortunately, we deal with that a lot from extension or just academia in general, is that there's a lot of so-called experts. Mm-hmm. So lastly, in your opinion, what sets apart a successful beef professional from someone that isn't?
This might be a geneticist's answer, but measurements, metrics and either objectives, deliverables, or, they're really good. And I'm talking here beef operators. They'll know their profit per hectare or acre or whatever off the top of their head, in a heartbeat. And I think then they know that because they've got all the metrics to be able to do the calculations on that. And so I think, and more generally, just professionals that like they've got, what they're going to hit this year in terms of what they're going to achieve. I think having a goal and setting metrics around it and then measuring it and making progress towards it is the way to go.
No, I think, we're both data scientists, so data is important, but, our best producers are the producers that measure data, have data, and make decisions based off of data. And it's not this, I'm looking at something and visually they think something. They actually are using their data to make those decisions.
We're probably not going to disagree with each other. So a scientist asking another scientist.
Well, Alison, thanks for jumping on. Really enjoyed it. A lot of cool stuff on the biotech. The future of beef industry is going to be interesting when you start looking at all this new technology that can come in and play to help sustainability of cow-calf producers and feedlot as well.
Yep, exciting times for sure.
All right, thank you.